Okay, YouTube, in our last video, we kind of explored this idea of conic sections, this idea that if we had a double napped cone and we sliced it with a two-dimensional linear plane, we could create these four basic shapes. And in this video, what we're going to do is we're going to focus on this idea of a parabola and start by defining what a parabola is. And so in terms of all of our conic sections, what we are going to refer to them as is a locus of points. And that would be a set of points here, as we define a locus, is a set of points satisfying a given geometric property. And so when it comes to parabolas, we define them as being the set of all points x, y. So a locus of points, or a collection of points x, y in a plane that are equidistant, or the same distance from a fixed line that we're going to refer to as a directrix, okay, and a fixed point that we're going to refer to as the focus of our parabola here, that is not on this line. So when we look at our parabola here, we've talked about parabolas before in the past. We've often represented them with this ax squared plus bx plus c form here, or standard form. In this case, what we're doing is taking a purer look at this and saying that, okay, well, really what a parabola is this set of points here. And I suppose we could pick any point on the outside. We would refer to this x, y. But we're saying it's the set of points that are equidistant from a fixed line called the directrix and a fixed point called a focus that's not on that line. So looking at the parts of our parabola here, we have our u, okay, and we have the axis of symmetry that runs through the vertex of the parabola here. But the 2 points that I want to, or I don't want to say points, the two characteristics that I want to point out to you are this line that we refer to as the directrix, and it's not really there, we kind of just draw it in, and then this point called the focus. And so the interesting thing about parabolas, and I've already actually constructed one of these, let me pull it open here, is this. We would see that this parabola that I've created here, the directrix is this line that is not on the parabola, and our focus is this point here, C. But what you can see is, as I measure these distances of any point on the outside here, and I just want to show you this here, this could be any point on the outside of our parabola. If I were to measure the distance from this point to this point that we call the focus, and the point down to this line called the directrix right here, then what we would find out is that that distance is precisely the same no matter where we go on this parabola. And so I know it's kind of hard to read here, but they're both 9.9. As we deviate closer or further away, we could see that this distance is always going to be the same, this distance from the focus and this distance to the directrix. And so one thing that I want to notice right off the bat is this. The focus actually is on the axis of symmetry of the parabola, okay? And the focus, since it's the same distance from any point on the, I guess every point on the outside of the parabola is the same distance to the focus as it is to the directrix, then one thing we could always say is this. Then the vertex is always going to be the midpoint kind of our focus and our directrix here. But what you can see is if I were to change this directrix, it's not going to matter in which direction we head. As a matter of fact, we could see that that axis of symmetry that runs through our vertex here still runs through the middle of our parabola here, and that every point on the outside is still the same distance away from the focus as it is to the directrix right here. And so what we're going to do is we're essentially going to pick apart some of the characteristics that we see of this parabola right here. And so we would say that a few things we want to mention. The axis of symmetry, okay? We would say that the axis of symmetry runs through the vertex of the parabola, this point right here, okay? One thing that we also notice, and this is always going to be true, but is that our vertex and our directrix and our axis of symmetry will always be perpendicular. So we say that the axis of symmetry on every parabola, symmetry, is perpendicular to the directrix. Okay. Other things that we want to mention here are things like, well, the vertex is always halfway between the focus and the directrix. So we'd say the vertex, which is we're going to see at HK, is always half of the distance between the directrix and focus. So the focus and directrix, okay, directrix. But we can see that this is always going to be the case where the focus lies inside the parabola. So the key characteristics of all of our parabolas are going to be that they have a vertex, okay, a focus, and a directrix. And we could see that this vertex point is always going to be between the focus and the directrix, and that our parabola is going to kind of run between those two things, because any point that we pick on the outside here, its distance to there and its distance to there would have to be the same distance. And so what we're going to look at is, now that we see that this is the definition of this, we're going to look at the standard form for the equation of a parabola. Now this is very important. When we talk about the standard form of a parabola, this is the form that we're always going to want to write the equation in, because it's going to tell us where the vertex lies, and it's also going to help us find where we would find the focus and the directrix here. So let's go ahead and start with our two forms here. You can see that we have vertically oriented parabolas, but we also have horizontally oriented parabolas. And in either instance here, you can see that this parabola here has some vertex, and we've labeled the vertex as being at the point HK. So HK, those will respectively give us the x and y components of our vertex value here. Now what you'll notice is that the axis of symmetry runs through the vertex, and that our focus must lie on the axis of symmetry, and that our directrix lies underneath the vertex here, but running perpendicular to this axis of symmetry here. So with respect to what we see here, you'll notice that there is this letter P. Now the letter P, we're going to make a little note here, okay? But we'd say P is the quote-unquote directed distance, end quote, from the vertex to the focus. So with every parabola, what we're going to see here is this value of P, which is going to show up in our standard form here. Basically tells us how many steps we have to take along the axis of symmetry to get to the focal point for our parabola here. And the neat thing about that is, because the vertex is always halfway between the focus and the directrix, we could see that we would go P units in the other direction from our vertex in order to find this directrix here. So in terms of where these points would lie, knowing that the directrix is a horizontal line, it would have to have the equation y equals a number. And in order to find this value here, we could say that really this is at a y value that would have started at a height of k and then went down by p units here. So we can see that this directrix here is y equals k minus p. Now don't worry about memorizing this, but do know that it would be p units away from the vertex. And in terms of the focus, we could see that this is h comma k plus p, but because if we were to go p units in the direction of its sign there, we'd go p units upward, then we would be at this new point where we would still have the same x value, but we would have gone up p units. Now, when we mention directed distance here, okay, we're going to say p is a directed distance. If p is greater than 0, then the focus is above the vertex. So in other words, if p is a positive 2, we'll go 2 units above the vertex. If p is negative, however, if p is negative, then the focus is below the vertex. Another way to look at this is it opens up or opens down depending upon the value of p here. Okay, so now all of these things being mentioned here, that we have a vertex at h and k, and that p is this directed distance that tells us how to get to the focus and therefore will help us find the directrix. Now we want to look at the standard form of its equation and talk about how all of these things are related, and then we'll hop over here to the horizontal sense. But when you look at this here, what you're going to notice is that we have x minus h squared, the quantity squared, equals 4p times the quantity y minus k, and that this quantity here is to the first. And so one thing that I want to mention is that x is squared, but y is not. And so whenever we have a conic section where its equation has a squared one variable but not squared other variable, we're going to be looking at a parabola situation here. And so with respect to what we see here, we see that h is paired up with our x value and k is paired up with our y value, and this is always going to be a true thing, that h will be associated with k, or x, and k will be associated with y. And so we can see that looking at an equation in standard form like this, we could see that we would already know the values of the vertex here. And then from what we have here, this value out in front here being 4p, we could find out what the value of P is and then graph it by walking that many units from the vertex upward or downward to get to the focus and piecing the rest of this together here. And so our standard form equation is this x minus h quantity squared equals 4p times y minus k to the first. So now you'll notice that our squared quantity on the left here was an x squared thing. Now when we graph parabolas, or historically when we've graphed parabolas like maybe x squared minus 4, this would just be a parabola shifted down 4, okay? Something like this here, we could see that when our x thing was being squared, this was a vertically oriented parabola, vertically oriented. And we've not really graphed anything that's horizontally oriented yet. So let's go ahead and take a look at how this might look different if we had a horizontally oriented parabola. So looking first of all at the equation, the standard form of the equation, okay, you will notice that it is extremely similar, except for instead of x minus h being squared, it's the y minus k on the left side being squared. And on the right side, instead of 4p times y minus k to the first, we have 4p times x minus h to the first. So you can still see that h is associated with x, k is associated with y, and that our vertex is still at the point hk right here. Also this, we see that 4p here, p is the directed distance to get from the vertex to the focus, from the vertex to the focus. So we would say that if p is positive here, we're going to make a little note here, if p is positive, okay, then focus lies right of the vertex, okay? And if p is negative, okay, if p is negative, then the focus lies left of the vertex. In other words, focus lies left of the vertex. In other words, and I could put this on the left side here, essentially this opens right if p is positive, and it'll open to the left if p is negative here. But essentially you could see that from this equation we could tell exactly where the vertex is, just at hk, and then we could use the value of p to walk p units in the direction on the axis that is appropriate, if it's positive to the right, negative to the left, to find the focus. And once we find the focus, because we know that the focus here really would be at the same height value, but really would have been h plus p units to the right and at k, we could say that that distance there, p that we went to the right, we'd go the same distance, p to the left, and we would end up at this vertical line, so x equals a number, and we could see that this would really be x equals the original h value, or the x value at our vertex, minus p units here. We can see that this is also listed here. So again, no need to memorize these things right here. What we want to know is that h and k is the vertex, and that p is the directed distance to get to the focus, and that this is our standard form of an equation of a parabola. So what I want to look at essentially is just taking a look at a problem here, which it would be nice and easy. What we want to do is find the vertex, focus, and the directrix, and then sketch the graph of this parabola right here. So let's start with this. The standard form of a parabola, we can see that we have a y squared thing here. So would be this. We would say if we have a y squared thing, it would look like this: y minus k squared equals 4p times x minus h to the first. And so looking at what we have here, we actually have a y squared equals 3 times x. The interesting thing about this is, if we were to look at this critically, another way to interpret this is we have y minus 0 to the second power here. And we have over here on the right side, if I were to look at it this way, 3 times x minus 0 would be the same thing as what we have here. And so really interestingly, what we can see is that we have our k value, k always being associated with y. We have our h value here, h always being associated with x. And then most importantly, we actually have 4p. So one thing that I want to make sure that we write is this. We have h equals 0, k equals 0. So our vertex of our parabola is at the point 0, 0. So we've already found the vertex here. Let's go ahead and list that. Now the next thing that we want to make sure that we list here are the focus and directrix, but the thing is we know how to find the focus from the vertex by finding the value of p. The thing is, right now though, we don't know the value of p, we know the value of 4 times p. So if we were to take both sides of this equation and divide by a 4 here, what we're going to see is that we could come up with the fact that p must be equal to 3/4 here. And so because p is 3/4, let's go ahead and sketch out what we see so far. We know the vertex of this parabola is at 0, 0. And in terms of which way this is oriented, because we have a y squared thing, we're going to have a horizontally oriented parabola. So that means that our axis of symmetry has to run through this vertex in a left-right fashion. Here's our axis of symmetry. So along the axis of symmetry, what we're going to do is from 0, 0, we're going to walk p units, and in this case, in the direction that we want to go here is positive direction, we're going to go to the right. So we're going to go 3/4 of a unit to the right, and we're going to drop in this point right here, and we want to make sure we label this. This point right here must be 0 plus 3/4, comma 0, because what we did was we really went 3/4 to the right of where we had started at the vertex here. So we would say that our focus then, must be at the point 3/4, comma 0. Now likewise we say, well, where's the directrix? Now we know that the directrix has to run perpendicular to our axis of symmetry that runs through the middle of our parabola, and also that the vertex is the midway point, or the midpoint between our directrix and this focus point right here. This is our focus. Okay. So what we're going to do is we're going to go backwards 3/4 of a unit, and we're going to sketch in this vertical line right here, and we would say that this vertical line has an equation. This equation would be x equals the original x value that we started at, 0 here, minus the value of p. In other words, we could see that clearly this is the line x equals -3/4 here. So we would say that we found our vertex, we found our focus. What we want to do now is list our directrix. So we say our directrix, okay? And our directrix is at x equals -3/4. You could see that drawing the picture last is really the worst thing that we could do. What we want to do is kind of sketch the picture first to go back and look at its parts. So we say x is -3/4 here. So now to sketch the rest of this picture, what we know is that our parabola kind of runs through the vertex here and is cut in the middle between the directrix and the focus. So just to the best of our ability, what we'll do is we'll draw this parabolic path that kind of goes this way. And we could see that, you know, maybe these points on the outside here are equidistant to the directrix and the focus of the parabola right here. Cheers.